Welcome to Intermediate Statistics using SPSS. This video shows how to process the multiple regression test. You can watch the entire video or use the time slider to navigate directly to any time point. Multiple regression assesses the relationship between a variety of predictor variables and a continuous outcome variable. In this example, we have data from a smoking cessation program. The outcome variable, smoking status, is a continuous variable which contains the number of cigarettes that each participant smokes per day at the conclusion of the study. To better comprehend the variables that predict the outcome, in this case smoking status, the researcher gathers additional data from each participant. These are the predictor variables that are thought to be associated with the outcome variable, smoking status. Notice that the predictor variables can be continuous or categorical. The multiple regression processor will identify which predictor variables have a statistically significant relationship with the outcome variable, smoking status, and provide associated statistical details for each predictor. Multiple regression has 5 pretest requirements: N quota, linearity, homoscedasticity, multicollinearity, and normality. We'll check for N quota and linearity now. We'll assess the remaining 3 when we run the multiple regression. First, we'll derive the minimum required N quota, then we'll compare that to the N in the database. We'll use this same method to assess the N quota for logistic regression. Begin by listing all of the predictor variables contained in the model. Then identify the type of variable, either continuous or categorical. First, we'll focus on the continuous variables. There should be at least 10 records for each continuous variable. Next, we'll account for the categorical variables, beginning with gender. Gender contains 2 values. We compute 2 minus 1 times 10, which is 1 times 10. Race contains 5 values. We compute 5 minus 1 times 10, which is 4 times 10. We find that this model requires an N of at least 80 to produce robust results. This example uses the data set CH12 example 01 multiple regression.sav. To determine if the database has an N of at least 80, click on Analyze, Descriptive Statistics, Frequencies. Move the outcome variable smoking status into Variables and click OK. The smoking status table shows that the database contains 218 records. Since this exceeds the minimum of 80 required for this analysis, this pretest criterion is satisfied. For the linearity criterion, refer back to the N quota table, focusing on the continuous predictors. We need to check for linearity between each predictor and the outcome variable, smoking status. To do this, we'll order a separate scatter plot for each pair of variables and observe them for violations of linearity. We'll begin with age and smoking status. Click on Graphs, Chart Builder. Click on Scatter/Dot. Double-click on the Simple Scatter option or click and drag this icon to the chart preview area. Move age to the x-axis and smoking status to the y-axis. Then click OK. Repeat this process for income and smoking status, and once again for cigarettes and smoking status. The scatter plots show no violation of linearity. Hence, this criterion is satisfied. We'll check for the remaining 3 pretest criteria when we run the multiple regression. To process the multiple regression test, click on Analyze, Regression, Linear. Move the outcome variable smoking status to dependent and move gender, age, income, and cigarettes to independents and set method to forward. Click Next and move race.1, race.2, race.3, and race.4 to independents. If there were more polychotomous variables that had been dummy-coded, you would repeat this process for each variable. For example, suppose the data also included marital status, which contained 4 categories: single, married, separated, and divorced, along with the 3 dummy variables associated with it: marital status.1, marital status.2, and marital status.3. To load these dummy variables into the processor, you would click Next and then move the 3 dummy variables into the independence window. You can do this as many times as you need to, but make sure that all of the dummy variables that represent a polychotomous predictor variable are loaded together in each next block of data. To proceed, click on Statistics and check R-squared change and collinearity diagnostics. Click Continue, click Save, and under Residuals, check Unstandardized. This will generate the temporary variable res_1, which we'll use later to assess for normality. Click Continue, click on Plots, and move Z predicted to Y and Z residual to X. Click Continue, click OK, and it'll process. Now we'll finalize the 3 remaining pretest criteria: homoscedasticity, multicollinearity, and normality. To assess for homoscedasticity, observe the scatter plot of the dependence variable smoking status. We see that most of the points are within the plus or minus 2 range, which satisfies the homoscedasticity criterion. Next, we'll check for multicollinearity. On the coefficients table, observe the last block of figures in the VIF column. Since the variable inflation factor is less than or equal to 5 for each of these predictor variables, this indicates that multicollinearity is not an issue. This satisfies the multicollinearity criterion. The final pretest criterion, normality, pertains to the distribution of the residuals in the outcome variable, in this case, smoking status. We ordered the regression processor to calculate and save this data in the temporary variable res_1. To check for normality, order a histogram and normal curve for this variable. Click on Analyze, Descriptive Statistics, Frequencies. Click Reset to clear the Variables window. You can enlarge the window to get a better view of lengthy variable names. Move Unstandardized Residual res_1 to the Variables window. Click Charts and select Histogram with Normal Curve. Click Continue, click OK, and it'll process. The residual distribution for the outcome variable, smoking status, shows a normal distribution. Hence, this final criterion is satisfied. The primary results of the multiple regression are contained in the model summary table. First, focus on the rows where the p-value, the sig-f change column, is less than or equal to 0.05. These rows reflect the statistically significant predictors in this model. This table shows that age accounts for 53.1% of the variability in the current smoking status. Pre-treatment cigarette smoking accounts for an additional 4.5%, and gender accounts for an additional 2.1%. This concludes this video.